Okay, so today I'd like to introduce our capstone, the U.S. Economic Data Monitor, where we were developing comprehensive analytical insights into the U.S. economy through an interactive dashboard. For this presentation, we will cover an overview of the project and specific design challenges that we ran into over the course of it, and include a demo which clearly shows the functionality of our dashboard and how somebody would use it. Today, we are joined with me, Teasel, and then Liam as well to cover the demo. Starting off, we first want to discuss what the persona would be like, who the typical user of this dashboard would be. And the example that we wanted to iterate was going to be a macro trading analyst. So the profile could be someone that was working at a trading desk, at a bank or hedge fund that was focused on trading macro specific strategies. When trading macro specific strategies, you want to leverage economic data to be able to capture different trends and capitalize them across a wide array of different asset classes. For the background, it would be someone that's familiar with data analysis, who has stats background, which they understand how to use and leverage it, but they're not necessarily a programmer. So what we understand is that throughout our demo, we wanted to ensure that it was somebody that was comfortable with this type of information and that could use it effectively. Pain points for the specific persona would be hard to find relevant data in a central location, and existing tools would lack those interactive features. So currently, if they did not have access to a Bloomberg terminal, which had a very expensive subscription, they would have to figure out a way to effectively centralize this data, which we have clearly done, and we provide different ways to visualize it through an array of different plots. And then for use, they're going to explore this data and see how it pertains specifically to inflation, unemployment, and growth to find different trends to structure trades, regardless of what type of trading desk they're on. So it provides a lot of flexibility on that end and helps them develop a stronger view into the US economy at this current point in time. So I want to start off looking what the analyst thought process looked like. And typically it would start off with idea generation. Here, they're generating different ideas based on current market news and sentiment. So, for example, the analyst could be reading the Financial Times and Economist and trying to develop different trends that fit the current economy and then figure out how they can structure this and how they can monetize this for a different trade, depending on the fund that they work at and the mandate. So then moving on, they want to analyze empirical data. So they want to be able to parse through this historical data and then apply different statistical forecasting to be able to determine where things are going. This becomes very pertinent in the current economic regime because there has been a lot of volatility and a lot of opportunities for funds to make money. And then finally, to move on, there's going to be developing a strong market view where they use this data analysis and then develop comprehensive views, which will help them find insights into the economy. So together, this thought process is currently what they use, and our dashboard is going to fit exactly into providing value in this process through multiple different steps. So looking at that, we wanted to clearly define what our problem statement was. And like what the current issue for macro trading analysts is that data is very fragmented across multiple sources. So realistically, they want a centralized location where they're able to find this data and leverage it quickly and efficiently. Whereas what happens now, it's a very cumbersome process and it takes a lot of time. Existing tools do lack the proper infrastructure and they do have very expensive subscriptions. So, for example, a Bloomberg terminal would cost $25,000 per year for just a basic account. Whereas what we would like is to be able to bring this in an easy to use way, leveraging free APIs. Impacts of lacking this central location is that it does slow analysts down and limit their total bandwidth because they have to spend so much time pulling data and bringing it together to plot it. This limits analysts from being able to quickly attend to different market trends and rebalance their portfolios as things change. And then finally, what our solution is an interactive dashboard which consolidates all these different data sources and allows them to provide in-depth visuals with the ability to do comprehensive data analysis in one spot, quickly, efficiently, and with a wide array of different statistical trends that we can model. I want to kind of delve into the supporting technologies that we used. So with a full stack application like this, we had to consider the front end, the back end, the database, and the different APIs we were going to use to be able to extract the most value. So for the front end, we use React and Tide. For the back end, we used a mix of the TypeScript. For the database, we used MongoDB. So we used the non-relation-based database to be able to leverage all the information that we had. And then to be able to collect all of this data, we used the Fred API. The Fred API was very effective because it's run by the St. Louis Central Bank, and they provide good quality data that scales back to the 1980s. So analysts are able to both look for long-term trends and short-term trends, which is ideal for an application like this. So, in total, introducing our product, it's the US Economic Data Monitor, where it's a centralized platform for analysis. It's a unified economic data hub which brings together key indicators from the US economy in one easy to use location. It does have real-time updates, so it's continuously fetching and refreshing data, so they're able to look at how things are changing in the current term and then figure out how they can structure that. And then we made sure to emphasize a very user-centric design, where there was an intuitive interface which was tailored for analysts and tailored for specific things that they would look at on a day-to-day and be able to track those trends as they change as time progresses. Some of the key features and capabilities that we made sure to outline is comprehensive data access. So the three key areas that we focused on were inflation, unemployment, and growth data. And the Fred API provided this in a very effective way, and we figured out how to structure that and organize it effectively. We made sure to include interactive visualizations with customizable charts, which analysts could use, and then they could visualize these different trends and figure out how they can capitalize on them. And finally, we provided some analytical tools like correlation analysis and trend forecasting, leveraging a few AI tools to be able to determine how things are changing and how those relationships will converge in the future. Now we'd like to move on to our demo of the application.
All right, thanks, Keenan. So I'm going to give you guys a little demo of the main dashboard here. So here's the main dashboard. It presents 10 key economic indicators at a glance. So these include things like GDP, unemployment rates, inflation, US Treasury yields, and more. So each indicator right now, at least on this screen, shows data spanning back 10 years. So allows you a pretty comprehensive look at long-term trends. So at a quick glance, you can see how each of these indicators have evolved over time, but the real power is like the interactive features we included. So here, let me click on unemployment rates, for example. So it gives you a clearer look at its performance over time. Oh, let me load. There you go. And depending on how you adjust the time scale based on your needs, you can analyze data from all time, 5 years, 1 year, 6 months, 3 months, and we even added a custom option. So you could pick the specific day range you really wanted to go into. One of the main powerful tools I would say is our insights feature. Oh, so basically, it runs a set of calculations that help understand the significance of an indicator's movement. And these involve trend analysis, volatility measurement, outlook prediction, and just key statistics and importance field. So basically makes it quickly to extract meaningful insights without manually running the calculations yourself. And a key feature there you saw a second ago before I closed it was the ability to compare multiple indicators. So we have US and unemployment rate, so we can compare it with initial job claims. And yeah, so this compare feature provides you like a visual statistical representation of these relationships. And when we compare two indicators, we can take the analysis a step further. So if you click on Insight again, this time the dashboard should calculate correlation metrics. So helping us determine whether it's moving together, opposite directions, or a little to no relationship. So that's a pretty important tool that we added. And obviously another useful tool is just the ability to print and save your analysis. So at any point you can generate a snapshot of the graph, download it for reporting, presentations, or even further analysis that you have to do. But yeah, that basically concludes the overall main part of the dashboard. I'll pass it over to Liam here. He'll talk about the little bit about the AI model and the forecasting features that we added.
One.
Thank you, Teasel. That brings us to the model portion, which is really where financial analysts can take what they learned in the dashboard and try to create their own insights using an XGBoost model. To start, we have our dependent data series, which is whatever we want to really look at and determine what gets affected by the different independent data series. So I'm going to choose the CPI index, which has been a very, very hot topic in recent years. From there, you can choose different independent data series to see how these different series affect the main dependent data series. So here I'll choose the 2-year Treasury yield, and then perhaps I'll add another one using this feature where I can add something else, such as the Fed funds effective rate. From there, we only have one model at the moment, but are planning on looking into different models to be able to provide more versatility to financial analysts with the hope that they can use more than one model to determine exactly what they're looking at and inform their investment decisions. From there, we can select start dates of when our model wants to start from. So I will change this to an arbitrary date, such as December 2020. From there, we click this refresh analysis and our model gets to work. We're using an XGBoost model and SHAP analysis within this. SHAP analysis is just something that for each independent data series or feature, it assigns an importance score and tells us exactly how important it is to our dependent data series. So to start, we could look at, we could go down and see the mean absolute SHAP values. The mean SHAP values essentially are for every single data point, how important the independent data series were to the dependent data series. So starting from 2020 with quarterly information, I'd imagine we're getting 16, 20 data points. And for each of them, there would be an importance score assigned. And this is the mean of that. So we can see that for the US CPI index, the Fed funds effective rate is far more important in the SHAP value, meaning that it has a larger effect on the CPI than the 2-year Treasury yield. Moving down, we have our raw SHAP values. This is, as I mentioned before, for each of the data points, you get one single SHAP value. And we can see here, we plotted it on a B-storm plot. And this allows us to see every single raw SHAP value and how it affects itself. So you can scroll through, you can use the graph to be able to analyze exactly what's going on here. And we can see that when they're more concentrated on either side, either a positive or a negative, then the mean value would be higher. So in this case, we can really visualize and see that the federal funds effective rate has a much larger impact on the CPI than the 2-year Treasury yield. From there, you're probably asking about what these different use cases would be. So a raw SHAP value would be used to debug or just justify specific decisions and predictions. So this is less so making a large investment decision because it is the instance of a single sample. Whereas the mean SHAP values are for kind of a global model understanding. So this is to validate an entire model. So if you're making an investment thesis, validating the entire model to identify different, the most dominant drivers, as shown here, which was the Fed funds effective rate, and then really simplify the model to remove the unimportant features. So if we were to redo this and add a ton of different other series and then refresh this, once our model loads, we would see that some things would just very clearly be unimportant, such as US GDP per capita. US GDP per capita in this model has essentially no impact on the CPI index. So moving down to US GDP per capita, we could see basically nothing, in which case we could remove this and our model would become more efficient and still accurate. Something else that we featured in here was that this is always going to be sorted so you can see what's important at the top and what's unimportant at the bottom. And overall, we think that this is going to be an excellent tool for different financial analysts to be able to analyze the macroeconomic environment of the states and in the future, countries all around the world.
Perfect. Thank you so much for that demonstration. So effectively, after analyzing the demonstration, we want to take a more holistic view about how our systems diagram look. And then for the rest of the presentation, we're going to be covering some design challenges and our team processes to cover our workflow processes. So looking at this diagram, we want to show how the client, the server, and the storage work together. What we currently have is we use the REST API on the client end to connect to the web application. We have the database, which was the MongoDB, and the non-relational structure that we chose to go with. And here you can see the relationship between the machine learning engine, the server, and the data transformation engines. So one of the key things is that we would take the data, we would transform it to be able to normalize it and come up with effective conclusions, and then we would use the machine learning engine to come up with predictions between them. So moving forwards, what we wanted to cover is the team process. So looking at the team process, team culture and morale was very important to us, and it was something that we continuously iterated over the course of the project. So we used Agile framework, which was something that we covered in our past projects and something that was very important to us. And we use this framework to effectively develop and use concepts learned in class. So this became kind of the key crutch that we had and that helped structure all of our thoughts and ideas and helped us work effectively as a team. Roles and team dynamic was very interesting and very important to us throughout the project. All of us kind of had different backgrounds, so it's important to be able to leverage that. Liam and Teasel had experience in software development, whereas I had experience working in capital markets. So we were able to take the idea of our project and then also how we would technically implement it. So clear roles were established and support was provided when members were struggling. For example, there was a few scenarios where I did not have the same technical knowledge as them. So they were able to help teach me and help me understand the system's architecture. And I was able to provide some compliments on the technical side and bringing that together. And then finally, the last part of our team process, which we made sure to emphasize, was the communication channels. To have a good working team communicating constantly was of utmost importance. So we met weekly to discuss progress and shortcomings that we fell into. So over the course of the project, of course, we had challenges and we made sure to kind of use each other as crutches and help each other develop over the course of that, which was really great to see. By the end of the project, we had a really good team flow and the culture and morale was at all-time highs, which was great. And whenever we ran into stressful scenarios, everybody kept their cool and was able to work together really well, which was kind of supplemented by this process and making sure it was so structured. I want to kind of delve more into the challenges that we faced and kind of the solutions that we found to be able to fix them. One of the challenges that we initially had was balancing the simplicity of the project while ensuring that there was also enough depth for a technical trading analyst to use this. So what that meant is that we had to design an interface that was both intuitive for non-technical users, which didn't have a programming background, but it was powerful enough to kind of gain key insights into the economy. What this meant was kind of avoiding information overload and avoiding the use of too many features, which was something that we really tried to include. If we had too many features, it would be too complex to use, whereas if we did not have enough features, it wouldn't be intuitive and it wouldn't be helpful. So it was kind of determining how those things could work together. Performance and scalability was definitely a challenge as well. We wanted to make sure that we had high performance with the data processing and visualization, even with the large data sets that we used. So the thing that we touched on a little bit earlier is that the Fred API provided us data going back to the 1980s. But to be able to effectively pull this and make sure that it was working in an optimized environment, we had to make sure that performance and scalability were of utmost important. And optimizing those queries and backend architecture to handle real-time updates was really important because if our database was not effectively updating, then analysts would have stale data and weren't able to leverage it to kind of capture key trends that are happening at this current moment in time. And then finally, we wanted to make sure that there was user customization and accessibility. One of the key things that we noticed is that users wanted to have the ability to be able to change things. Well, it was still accessible and easy to use. So those custom views was something that was important to consider, and ensuring a clean layout, which allowed the analyst to kind of leverage that, was one of our key challenges at the beginning. But I think we were able to effectively bring that together, which was shown for our demo a little bit ago. Key successes, the things that we did well over the course of the project was definitely the integration of the predictive model. We wanted to kind of leverage the AI stuff we were learning in our classes. And a key feature of the dashboard was the integration of that AI-driven predictive model, which could help generate reliable forecasts. This was great because even if you look at the other subscriptions that we talked about earlier, they did not provide AI insights. So we believe this was really interesting and a really good way that analysts could structure different trades and adjust their strategies. Another success was our comprehensive coverage of indicators. As I mentioned earlier, the three key areas that we looked at was inflation, unemployment, and growth. And we were able to bring all of those together and structure in a really nice layout, which allowed analysts to kind of segment them and realize the relationships between them. So it kind of encompassed a holistic view of the American economy, which was really good. And finally, it was the real-time analysis with the data refresh. As I mentioned earlier, a stale dashboard is not helpful for anybody. Looking at data that's already happened 6 months in the past, it is helpful, but you want to be able to know what's currently happening at this current point in time, as these economic indicators do update weekly, monthly, quarterly, depending on the specific one. So the ability of the dashboard to process and present real-time data was one of the key strengths that we had, and it allows analysts to rapidly shift to changing market conditions. So now I want to outline areas for improvement. After looking at our final project, we wanted to see if we had more time, where could we improve specific things, and how could we allow analysts to be able to use this to an even more effective extent. So I guess the first thing we wanted to mention was the better handling of user inputs for custom selection. Customizability was one of our key focuses, as we mentioned. So in the future, what we would add is the dashboard offering customized data selections and a location where analysts could specify and adjust different timeframes is currently cumbersome under the way that we're running it. So this is something that we could improve. Streamlining the input as well could make it more intuitive and improve that overall experience. So this is a next step that could be definitely added. And another thing that we'd like to talk about a little bit more is optimizing the data processing speed. Since we did say that there could be a significant look back period, it doesn't make sense if you have to wait a significant more time to be able to pull data from like the 80s and 90s compared to if you're pulling data from 6 months ago. Otherwise, it becomes very slow to use the platform. So for us in future iterations, it becomes important to refine the data processing pipeline and enhance that performance, which allows for quicker responses moving forwards. And these are areas that could be improved upon, but we think did not fit the current scope of our first sprints. And then I kind of want to talk about next steps that if we did have more time, what we would do and what we would change. So I think refining the AI model is always something that can continue to get better and better. Obviously, given more time, you're able to further develop and test the AI-driven predictive model. And then what you could do is like you could come up with the implications that it's telling you at this current point in time and test them how they perform under current market conditions. So that's something that we would want to do, and we'd like to have a way to test the accuracy of the model. Then after that, it's going to be gathering user feedback. Performing tests with analysts that are actually in the industry would be super helpful. Since our target segment is relatively niche, it would be great to be able to talk to them and be like, what do you guys think about this? How does this differ from other subscriptions that you're currently using? And what would you change? And I think that's one of the key things, especially with capital markets technology. It's very important to talk to the user and optimize for them, because if it's too slow, they would look for other alternatives. Other things are adding more enhanced analytics. Currently, we had kind of our suite of different statistical features that we offered. We would like to allow different ones and more intricate ones to allow users to explore deeper relationships moving forwards. And finally, expanding the data. For this one, we looked at the US economy. It would be great if you could look at Canadian economy, Eurozone economy, and be able to come up with cross-market implications between them. And that's something that we would kind of want to change moving forwards. But as of now, I think our first release is going to be the US economic data and being able to figure out what is going on there. And then finally, I wanted to cover lessons learned and key things that we learned across the process. Firstly, like it's the importance of collaboration. Effective collaboration promotes creativity in group settings. So through being able to work together and having strong team morale, it helped us brainstorm different perspectives, which was very helpful over the course of the project. Frequent communication was very important. Originally, we started meeting every 2 or 3 weeks, and then we started increasing that as time went to be able to have more touch points and really understand what people were struggling with, what they were working on, and what they thought we could improve. And then trust and support were vital. What we learned is that being able to trust each other and being able to give tasks to somebody and having the utmost confidence that they would finish it was very important, which was something that was really good that we saw as the project continued. And finally, adaptability and open mindset were key as well. And that was one of the main lessons that we took away. Having an open mindset when approaching a problem like this was really important because changes had to be made. Obviously, you had the first vision of what you expected, and as you started to iterate, that changed slowly as time went. So we encountered unexpected issues, but the learning and the open mindset helped us quickly adjust and have no issues with those. Staying positive when things didn't go right was very important. Many times, like we tried to implement features that ran into issues originally, but being able to plan that and get across that was really important. And understanding the importance of patience in a large group was also very, very important. When you're working with multiple people on a project this large, being patient and understanding that mistakes will be made is something that we understood, and it helped out greatly. So thank you so much for watching our demonstration, and this kind of covers the demonstration of our app and different design challenges from the start to implementation. Thank you so much.